In the spring of 1943, the Allied war effort faced a series of targets so massive, so strong, they were considered indestructible. Deep in the industrial heart of Germany, the colossal dams of the Ruhr Valley stood as man-made mountains of concrete and steel, powering the Nazi war machine. Further north, in the heavily fortified ports of France, monstrous concrete submarine pens, with roofs over 20 feet thick, provided safe haven for the U-boat wolf packs that were strangling Britain. And hidden in the fjords of Norway, the mighty German battleship Tirpitz, a floating fortress of Krupp steel, posed a constant fleet-and-being threat to the Allied convoys. These were not just targets, they were symbols of the Reich's power, fortresses that mocked conventional weapons. Conventional bombing raids had proven useless, the bombs barely scratching their surfaces. Torpedoes were impotent, blocked by nets in shallow waters. To win the war, these strategic linchpins had to be destroyed. But how do you destroy the indestructible? The answer would come not from a committee of generals, but from the obsessive, brilliant mind of a single engineer. An idea so audacious, so counterintuitive, that his superiors initially dismissed it as madness. He would arm a legendary squadron with a weapon that broke the laws of physics, a bomb that could skip on water like a child's toy. And then he would perfect an even greater weapon, a bomb that could create a man-made earthquake. This is the declassified story of the Dambusters, the legendary 617 Squadron, and the two impossible weapons they used to shatter Hitler's fortresses. This is the story of how you destroy the indestructible. This is the unseen front.
The story begins in early 1942 with a single obsessive British aircraft designer, Barnes Wallis. Wallis was not a typical military engineer. He was a visionary, a man who saw solutions where others saw only impenetrable problems, and he was famously, stubbornly persistent. Already renowned for his innovative geodetic airframe design for the Wellington bomber, a lattice-like structure of woven metal strips that was incredibly strong yet lightweight, Wallis was haunted by the inefficiency of conventional bombing. He saw dropping thousands of small bombs from high altitude as a statistical lottery, a terribly wasteful and inaccurate way to destroy precise, hardened targets. He became obsessed with the idea of creating a perfect bomb, a single, massive weapon that could strike with overwhelming force and surgical precision. His mind turned to the colossal dams of Germany's Ruhr Valley, the Möhne, the Eder, and the Sorpe. These were not mere walls, they were the heart of the German war machine, providing water and hydroelectric power to the entire Ruhr industrial region. Wallis knew from basic physics that the most effective way to destroy a gravity dam was not to attack its thick, sloping face, but to place an explosive charge directly against its base, deep underwater. The incompressible nature of water would contain the blast, preventing energy from dissipating into the air, and focus all of its explosive force directly into the dam's structure, shattering it from the inside out. The problem was delivery. The dams were heavily defended by anti-aircraft batteries and, more importantly, massive underwater torpedo nets stretched across the reservoirs, making a conventional torpedo attack impossible.
Wallis's initial audacious concept was a gargantuan 10-ton earthquake bomb dropped from the stratosphere at 40,000 feet. It would be aerodynamically perfect, reaching supersonic speeds and penetrating deep into the earth before detonating, creating a seismic shockwave that would shatter the dam's foundations from below. But the RAF had no bomber capable of such a feat, and the military establishment viewed Wallis as an eccentric dreamer. Frustrated but undeterred, Wallis went back to his first principles and found his inspiration in his own backyard. The legend, confirmed by his daughter, is that the eureka moment came while he was skipping marbles with his children across a tub of water. He noticed that if he gave the marble backspin as he threw it, it would hug the surface, traveling much further and making many more skips before sinking. A revolutionary idea was born. what if a bomb could be designed to do the same? A cylindrical bomb, dropped from a low altitude and given a powerful backspin, would not plunge into the water. Instead, it would skip across the surface like a perfectly thrown stone, bounce clean over the defensive torpedo nets, and, upon reaching the dam wall, use its remaining forward momentum to cling to the concrete as it sank. The backspin would press it tight against the dam's face, ensuring it reached the perfect detonation depth at the foundation, thanks to a hydrostatic fuse. It was a plan of breathtaking, almost insane genius, a weapon that treated the surface of the water not as an obstacle, but as a delivery path. When Wallis presented this idea to the military authorities, the reaction was a mix of disbelief and ridicule. It sounded like something out of a pulp science fiction novel. A skipping bomb? It was absurd. The physics seemed impossible. But Wallis was relentless. He produced a short film demonstrating the principle, and with the backing of the Chief of Bomber Command, Air Chief Marshal Sir Arthur Harris, he was given the green light for limited testing. The experiments were fraught with failure. The challenges were immense. The bomb had to be a perfect cylinder to maintain stability. It had to be dropped from an exact, suicidally low altitude of just 60 feet. It had to be flying at a precise speed of 240 miles per hour. And it had to be spinning backwards at exactly 500 revolutions per minute. Any deviation, and the bomb would either plunge too deep, bounce erratically into the air, or, as happened in many early tests, disintegrate upon its first violent impact with the water. The early prototypes, made of wood, shattered instantly. The first steel casings, dropped at Reckover Bay, buckled and warped. The physics was unforgiving, but through brutal trial and error, filming each drop with high-speed cameras and analyzing the failures, the design was slowly perfected. The final weapon was codenamed Upkeep. It was a giant, 9,250-pound, over 4 tons, steel cylinder, 60 inches in diameter, looking more like an industrial water heater than a bomb. It was filled with 6,600 pounds of Tirpitz, an explosive 50% more powerful than TNT. To achieve the crucial backspan, a special hydraulic motor, powered by the bomber's own systems, was installed in the bomb bay of a specially modified Avro Lancaster. Just before the drop, this motor would spin the bomb up to 500 RPM. The bomb itself was held in place by a pair of V-shaped calipers. Dropping it was a simple, yet terrifyingly precise, matter of opening the calipers and letting the spinning behemoth fall. The modified Lancaster, the Type 464 provisioning, was a marvel of its own. The bomb bay doors had to be completely removed to accommodate the unconventional weapon, leaving the massive spinning cylinder exposed to the airstream. The extra weight and significant aerodynamic drag made the plane incredibly difficult to fly, especially at the suicidally low altitude the mission required. The project was the epitome of high-stakes, bespoke engineering. While Wallis was perfecting his weapon, the RAF was tasked with finding the men who could wield it. In March 1943, a new top-secret squadron was formed, number 617 Squadron. To preserve secrecy, it was initially designated Squadron X. It was composed of the best and most experienced bomber crews from across the Commonwealth, British, Canadian, Australian, and New Zealander airmen. Its commander was a 24-year-old flying prodigy, Wing Commander Guy Gibson, already a veteran of over 170 missions and a decorated hero. He was a brilliant pilot and a strict, demanding leader, known for his relentless perfectionism. He was told only that his new squadron had a secret, critically important mission, and that they had less than 2 months to prepare for it. The nature of the weapon and the target were kept a closely guarded secret, even from the pilots themselves, until the final hours. The crews began their intense training, practicing low-level flying over British reservoirs, completely unaware of the true purpose of their dangerous maneuvers. They were a hand-picked team of flying virtuosos, being prepared for a mission that many in the high command still believed was impossible. The training for 617 Squadron was the most intense and dangerous of the entire war. The pilots had to learn to fly a massive 4-engine Lancaster bomber with a wingspan of over 100 feet, as if it were a nimble fighter. Their lives depended on maintaining an exact, unwavering altitude of just 60 feet above the water at night. Flying any higher and the bomb would shatter on impact. Flying any lower and the plane's own propellers would strike the water, causing a catastrophic crash. Standard altimeters were useless at such low heights, their readings inaccurate and slow to update. To solve this problem, a brilliantly simple solution was devised. 2 spotlights were mounted on the aircraft, one under the nose and one under the fuselage, precisely angled so that their beams would converge into a single figure 8 shape on the water's surface only when the plane was at the perfect 60-foot altitude. The pilot's job was to fly so low that these 2 spots of light became one, a terrifyingly precise task in a lumbering heavy bomber in the dead of night. But altitude was only half the problem. The bomb had to be released at a precise distance from the dam wall for the skip and sinking to work correctly. Standard bomb sights were useless at this low altitude. The solution, again, was wonderfully simple and improvised, a testament to the ingenuity born of necessity. The squadron's bombardier, Flight Lieutenant Harrow Danny Walker, created a handheld targeting device that looked like a child's slingshot. It was a simple wooden triangle with a peephole at one corner and a nail driven into each of the other 2 corners. The bombardier would look through the peephole, and when the 2 nails on the device lined up perfectly with the distinctive towers on either end of the dam, he knew he was at the correct release distance. The lives of the crew, the success of the mission, and the fate of the bouncing bomb depended on a piece of wood and 2 spotlights. It was the ultimate marriage of high-tech weaponry and low-tech improvised genius. On the evening of May 16, 1943, the mission, codenamed Operation Chastise, was a go. 19 modified Lancasters of 617 Squadron, each carrying 1 spinning cylindrical bomb, took off into the night from RAF Scampton. Their flight path was a suicidal low-level dash across the English Channel, over Holland, and deep into Germany, flying at treetop height to stay under German radar. In the final briefing, Guy Gibson revealed the targets. For the first time, the crew saw the detailed models and photographs of the massive Monet, Eder, and Sorp dams. Gibson's final words to his men were stark and without illusion. "This is going to be a sticky trip, but if we can pull it off, we'll make history." The flight in was a battle in itself. Flying at less than 100 feet, they had to navigate by map and compass, dodging high-tension power lines and German flak towers that fired down at them from above. 2 Lancasters were lost before they even reached the target area, one flying into the sea and another hitting power lines. Just after midnight, Gibson's formation arrived at the first and most important target, the Moan Dam. It was a terrifying sight, a colossal wall of stone and concrete, 130 feet high and 80 feet thick at its base, bathed in the eerie light of the moon. As they approached, the German defenses erupted. The dam was heavily defended by 20mm anti-aircraft guns positioned in towers at either end. Gibson went in first to draw the enemy's fire and test the defenses. He brought his Lancaster, call sign G for George, down to the shimmering surface of the reservoir, his co-pilot calling out the altitude as the 2 spotlights converged on the water. Down a bit, steady, steady. Flak tracers like red-hot chains ripped through the air around them. At the perfect moment, Gibson shouted, "Bomb gone!" The crew felt a lurch as the 9,000-pound weapon was released. They watched as the bomb hit the water, skipped 4 or 5 times in enormous theatrical splashes, hit the dam wall, and sank. A few seconds later, a colossal plume of water erupted hundreds of feet into the air, but the wall held. Gibson circled back to direct the next attack, deliberately drawing the flak towards himself to protect the other aircraft. The next plane in, flown by Flight Lieutenant John "Hoppy" Hopgood, was hit by flak on its approach. With an engine on fire, Hopgood pressed on, releasing his bomb just before his aircraft exploded in a massive fireball, tragically killing all but 2 of his crew. The third plane, flown by Squadron Leader Melvin "Dingy" Young, made its run. Again, a perfect drop. Again, a massive explosion. The dam was now clearly damaged, water cascading over the top, but it still had not broken. It was now the turn of Squadron Leader David Maltby. As he made his run through the hailstorm of flak, his aircraft was hit multiple times, but he held it steady. He released his bomb. It skipped perfectly, hit the already weakened section of the wall, and sank. There was a pregnant pause, and then a cataclysmic explosion. The center of the Great Mern Dam seemed to lift into the air and then disintegrate. A torrent of water, a 30-foot-high tidal wave, began to pour into the valley below. Gibson, circling overhead, transmitted the triumphant prearranged code word, "nigger." It was the name of his beloved black Labrador, which had been tragically run over and killed just hours before the mission. For Gibson, it was a personal and defiant tribute. With the Mon destroyed, Gibson, his own plane now heavily damaged, gathered the remaining bombers with live weapons and led them onto the next target, the Eder Dam. The Eder was less defended but was nestled in a deep, winding valley, making the approach incredibly difficult. Pilots had to make a steep, banking turn at just 60 feet above the water to line up for the drop, a feat of almost superhuman airmanship in a 4-engine heavy bomber at night. After several harrowing runs that had to be aborted, Squadron Leader Henry Maudsley was hit by flak. His bomb struck the top of the dam and detonated, likely destroying his aircraft in the blast. Finally, Pilot Officer Les Knight, on the final attempt, achieved a perfect drop. The Eder Dam was also breached, unleashing another devastating flood into the valleys below. The third target, the Sorp Dam, an earthen dam of a different construction, was damaged by several attacks but was not breached. The mission was a partial but spectacular success. But the success came at a terrible cost. The flight back was just as dangerous as the flight in. The surviving crews, euphoric but exhausted, still had to navigate hundreds of miles over enemy territory at treetop height. The German night fighter and flak defenses, now fully alerted, were waiting for them. Squadron Leader Henry Maudsley's Lancaster was shot down over the Netherlands. Squadron Leader Young, who had dropped one of the successful bombs on the Mon, was also shot down by coastal flak. Others were lost to the treacherous low-level flying itself, clipping power lines or trees in the darkness. Of the 19 Lancasters that had set out with 133 men, 8 aircraft did not return. 53 highly skilled and incredibly brave airmen were killed, a casualty rate of nearly 40%. 3 more were captured after bailing out. When the survivors returned to their base at RAF Scampton, the mood was a somber, surreal mix of elation and profound grief. The ground crews, who had waited anxiously through the night, could only watch as just 11 bombers returned. In the officers' mess, the empty chairs of the lost crews stood as silent, heartbreaking monuments to the price of their victory. Guy Gibson, who had lost many of his closest friends, was awarded the Victoria Cross, Britain's highest medal for gallantry, for his incredible leadership and courage. In total, 34 gallantry medals were awarded to the survivors. The Dambusters, as they were immediately christened by the press, had become legends overnight. The immediate aftermath in Germany was a scene of chaos and devastation. The breaching of the Mon and Eder dams unleashed a biblical torrent into the Ruhr and Eder valleys. Nearly 330 million tons of water,
A wave that was initially over 30 feet high surged through the industrial heartland of the Reich. The flood was a destructive, unstoppable force. It swept away over 100 factories, destroyed 25 bridges, and severely damaged miles of railway lines. The flooding inundated crucial coal mines and wiped out dozens of power stations, causing a 75% reduction in the region's electricity supply. For a critical period, steel and armaments production in Germany's most important industrial region was severely disrupted. The psychological impact on the German leadership was equally profound. They had believed their dams were invincible, symbols of German engineering prowess. The raid proved that no target was safe from the reach of Allied ingenuity. Albert Speer, Hitler's armaments minister, flew over the devastation the next day and called the raid a disaster of the first magnitude. In his memoirs, he wrote that the raid came close to a catastrophe for the war effort. In a panic, he diverted over 20,000 workers from the critical task of building the Atlantic Wall defenses in France to repair the dams, a huge diversion of resources in the crucial year before the D-Day landings.
However, the long-term strategic effectiveness of the Dambusters raid remains a subject of intense historical debate. The Germans, with their characteristic and formidable efficiency, repaired the breached dams with astonishing speed. By late September, just 4 months after the raid, the dams were fully repaired and the reservoirs were refilling. The disruption to the Ruhr's water and power supply, while severe, was temporary. Some historians argue that the raid, while a spectacular tactical success and a massive morale boost for Britain, did not cause the lasting damage that was hoped for. They contend that the horrific loss of 53 elite airmen and 8 state-of-the-art bombers was too high a price to pay for a temporary disruption, and that the resources and skill of 617 Squadron would have been better used in the ongoing grinding bomber campaign against German cities and industry. But this view misses the raid's most important legacy. It wasn't just about destroying 2 dams, it was about proving a concept. It proved that Wallis was a genius, not a madman. It proved that 617 Squadron could execute the most complex and dangerous missions imaginable. And it earned Wallis the trust and the resources he needed to unleash his real ultimate weapon. The Dambusters legend was secure. But for Wallis and 617 Squadron, their most important work was just beginning.
With the success of Operation Chastise, the military establishment could no longer ignore Wallis. He now had the credibility to pursue his original and far more ambitious vision, the earthquake bomb. The concept was born from his understanding that destroying massive, hardened structures like concrete submarine pens or underground bunkers with a direct hit was almost impossible. A conventional bomb's energy dissipates into the air. But Wallis theorized that if a huge, incredibly heavy, and aerodynamically perfect bomb was dropped from a very high altitude, it could reach supersonic speeds. It wouldn't explode on the surface. Instead, its immense kinetic energy would allow it to penetrate deep into the earth, up to 100 feet before detonating. The underground explosion would create a massive shockwave, a man-made earthquake that would travel through the ground and shatter the foundations of the target from below, causing the entire structure to collapse in on itself. It was a revolutionary concept, turning the Earth itself into a weapon. To achieve this, Wallis designed 2 new bombs, a small 12,000-pound version codenamed Tallboy, and its monstrous big brother, a 22,000-pound behemoth codenamed Grand Slam. The design of the Tallboy was a masterpiece of aerodynamic engineering. To reach the required penetration speed, it had to be perfectly streamlined. It was 21 feet long, but only 38 inches in diameter, with a long, elegant tail section that gave it incredible stability during its fall. It was cast from a special high-tensile steel to ensure it wouldn't shatter on impact with the ground. It was filled with 5,200 pounds of Tirpitz, the same powerful explosive used in the bouncing bomb. To ensure detonation only after it had penetrated deep underground, it was fitted with 3 separate time-delayed tail fuses. The bomber tasked with carrying this giant was, once again, the Avro Lancaster. But it required extensive modification. The bomb bay bores had to be completely removed, and the bomb itself was carried semi-recessed in the fuselage. The sheer weight of a single Tallboy was so great that the Lancaster had to be stripped of all non-essential equipment, including defensive armor and some of its gun turrets, just to get off the ground. The mission of delivering these bombs fell, naturally, to the RAF's elite precision bombing unit, the veteran Dambusters of 617 Squadron. The first target for the new Tallboy bomb was a target almost as difficult as the dams, the Saumur railway tunnel in France. This tunnel was a critical bottleneck for the Germans, used to transport panzer divisions to the front lines to counter the D-Day landings in June 1944. Conventional bombing had failed to close it. On the night of June 8th, just 2 days after D-Day, 617 Squadron was sent to debut Wallis's new weapon. Flying at 18,000 feet, far higher than their Dambusters altitude, the Lancasters dropped their Tallboys. The results were stunning. One Tallboy directly penetrated the roof of the tunnel, exploding inside and causing a complete collapse. Another missed the tunnel but penetrated 60 feet into the rock beside it, triggering a small earthquake that sealed the tunnel entrance with a landslide. In a single raid, a target that had resisted all previous attempts was completely and permanently destroyed. The earthquake bomb worked. Now 617 Squadron was ready to hunt even bigger game, the seemingly invincible German submarine pens.
Der U-Boot-Pens an den Atlantikkust von Frankreich waren eine der most formidablen Strukturen ever gebaut. Sie waren gargantische konkrete Fortressen, designed zu Protection Germany's Submarine Fleet vom Air Attack. Die Pens at Brest, Lorient und Saint-Nazaire waren covered bei reverstärkt konkrete Rüfe, die über 22 Fuß, 7 Meter dick waren. Konventionelle Bomben simply bounced off them. Diese Pens waren eine Top-Priorität für die Allies, als die U-Boote sie hauste, waren still eine deadliche Trot in der Battle of the Atlantic. Im August 1944, 617 Squadron war an Folgeend auf sie. Auf dem 5. August, sie attackierten die Pens at Brest. Severe Tallboys wurden gedroppt. Ein Bomb in einem spektakulären Display auf seiner Kraft punched a clean hole recht durch den 22 Fuß konkrete Roof und detonierte inside dem Pen, komplett destroying 2 Submarines das were sheltering within. Für das erste Mal, die invinciblen U-Boot-Bunker hatten gebrochen. Der psychologische Effekt auf den German Submarine Crews, who hätten beglaubt, sie wären komplett sicher in diesen Pens, war devastierend. Der war nur noch kein Sicherhafen.
Having proven their worth against tunnels and bunkers, Barnes-Wallis and 617 Squadron were now tasked with hunting the pride of the German Navy, the colossal battleship Tirpitz. The sister ship of the Bismarck, the Tirpitz was a 52,000-ton floating fortress armed with 8 15-inch guns. It spent most of the war hiding in the deep, heavily defended fjords of Norway, posing a constant fleet-in-being threat that tied down a huge portion of the British Royal Navy. Numerous attempts to sink it had failed. In September 1944, 617 Squadron launched Operation Paravane. Flying from a forward base in Russia, they attacked the Tirpitz at its anchorage in Kafjord. One Tallboy, dropped by squadron leader J.B. Willie Tate, struck the battleship's bow. It didn't sink the ship, but the underground explosion from the near misses and the direct hit caused massive structural damage, rendering the great battleship no longer seaworthy. The crippled Tirpitz was moved south to Tromsø Fjord to be used as a static coastal defense battery. It was now a sitting duck. On November 12, 1944, 617 Squadron returned to finish the job. In an operation codenamed Catechism, 32 Lancasters took off from Scotland for the final attack on the Tirpitz. The weather was clear. The bombers released their Tallboys from 14,000 feet. The ship was hit by at least 2 and possibly 3 of the massive bombs. The effect was cataclysmic. One bomb penetrated the armored deck and caused a massive internal explosion. A huge cloud of smoke and flame erupted from the ship's port side. The mighty Tirpitz began to list heavily, its fate sealed. Within minutes, a violent explosion in one of its main ammunition magazines blew Turret C completely overboard. The battleship rolled over and capsized, its keel pointing to the sky, trapping nearly 1,000 of her crew inside. The greatest threat the Royal Navy had faced in the Atlantic was finally eliminated, not by another battleship, but by a handful of bombers and the genius of Barnes-Wallis's earthquake bomb. With the Tirpitz at the bottom of a fjord, Wallis and 617 Squadron turned their attention to the final evolution of their weapon, the 22,000-pound Grand Slam. This was the largest conventional bomb of the entire war, a 10-ton monster that Wallis affectionately called his Big Bible. It was 25 feet long and filled with over 9,000 pounds of Torpex. It was so heavy that the Lancaster that carried it, stripped of all armor and gun turrets, had to use the most powerful Rolls-Royce Merlin engines and could barely climb to its attack altitude. The first use of the Grand Slam came in March 1945 against the Bielefeld Railway Viaduct, a critical transportation artery in Germany. After numerous failed attacks with smaller bombs, a single Grand Slam was dropped by Squadron leader C.C. Calder. It impacted the ground 100 feet from the viaduct. The resulting underground camouflage explosion was so powerful that the seismic shock wave collapsed over 100 yards of the massive structure from its foundations. The final targets for the Grand Slam were Hitler's most secret and hardened command bunkers and V-weapon sites. In a series of raids in March and April 1945, 617 Squadron used the 10-ton bombs to destroy the seemingly impregnable Valentine U-boat assembly bunker near Bremen, which had a 23-foot thick concrete roof. They also obliterated several V-2 rocket launch sites, penetrating deep underground to destroy the bunkers and storage facilities. The earthquake bombs had become the ultimate bunker busters, the only weapon capable of destroying Hitler's deepest and most protected layers. In just 2 years, Barnes-Wallis's crazy ideas had gone from being ridiculed to becoming the RAF's most precise and powerful strategic weapons. He had armed a single squadron with the ability to destroy targets that entire air forces had previously failed to even scratch. The story of Barnes-Wallis and 617 Squadron is the ultimate testament to the unseen front. It is a story of how a single individual's intellectual courage and stubborn persistence can change the course of a war. Wallis was not a soldier. He was an engineer who fought his battles on drawing boards and in test facilities. His weapons were not rifles and cannons, but physics, aerodynamics, and an unshakable belief in the power of a good idea. The men of 617 Squadron, in turn, were not just bomber crews, they were the most skilled and precise aviators of their generation, the only ones who could be trusted to deliver Wallis's unconventional weapons. Together, they formed a unique partnership of genius and courage. From the skipping bomb that broke the dams to the earthquake bombs that shattered Hitler's fortresses, they proved time and time again that the most powerful weapon in any arsenal is the human mind's ability to solve the impossible.